towards the landing site. That would have been kind of the worst case. It would not have impacted our ability to land safely, just maybe cause us to land less accurately than we would like, a little further out towards the edges of that ellipse than the center. It also could have disappeared. That was actually the prediction by our atmospheric scientists on our team, that it would disappear within a day or two after seeing it 2 days ago, or it could have just drifted along the south polar cap where these storms tend to form. So let's see what happened. The Mars Reconnaissance Orbiter has taken global maps of Mars for us using the Mars Color Imager, and my colleague Bruce Cantor at Mail and Space Science delivers those maps to us every morning at 7:30 or so. And I'll show you on this Earth map first, just to orient you of how we view Mars in the same map format. Again, I'll point out north of Australia there, just about Indonesia, there's a little circle drawn on the map, and that's where Gale Crater is in the same location on Mars. So now if you go to the next Mars map, this is the most current map of Mars taken 2 days ago on August 2nd. What has happened is the good scenario, where that active dust storm, which was boiling at the surface and very well defined 2 days ago, has now evolved into a fairly harmless cloud of dust, basically the poof remnants of what was that dust storm. And that dust cloud is translating. It probably will not reach Gale Crater by the time we land, and if it did, the amount of dust in that cloud is not believed to affect the entry, descent, and landing in any meaningful way. We continue to see the water ice clouds over Mars. This is a good thing. We've predicted in years without bothersome dust storms, there should be a lot of water ice clouds in the atmosphere, because a cold atmosphere that's free of dust tends to have these water ice clouds at this time of year. So the more we see these clouds, the more we like it. Mars appears to be cooperating very nicely with us, and we expect good weather for landing Sunday night. We're going to continue to look at this one more time. Tomorrow morning we'll get some more recent data. And then I'll show you one final thing, just to show you what could have happened. We have 3 prior years of Mars data from the Mars Reconnaissance Orbiter, and what this image shows is a map taken by the Mars Color Imager 2 Mars years ago. This is from October 2008, just at the same time we'd be landing the spacecraft on Sunday night, but 2 full Mars years ago. And you can see that there's remarkably few water ice clouds. This particular year, Mars transitioned from its colder southern winter to its more dusty southern spring and summer earlier than we would have arrived, if we had landed 2 years ago. And the atmosphere warmed up, the water ice clouds disappeared, and the conditions in this year were very ripe for a lot more dust activity. In fact, days before and after this particular image, there was a lot more dust storms. And that's actually what we took into account when we designed the entry, descent, and landing capabilities for this mission. We had to be able to land in all the conditions we'd seen in previous years, and so that's what we've done. But fortunately, Mars is playing nice, and we're going to get good conditions for Sunday. I'll turn over back to you, Veronica.
All right, thank you. We're going to open it up to questions here in the auditorium. We'll start with the news media, and then we also have our NASA social participants here today with us, and we'll take some questions from them as well. So if you would raise your hand, and we'll get the microphones to you, and please give us your name and affiliation. We'll start here first, and then we'll go to the aisle next.
Thank you. Olivier Sanguy, enjoyspace.com from France. I'd like to know, in the first data you will receive from Curiosity, will you have a sort of health check of the rover, or just a beep?
So it depends on when we hear from it. That under the best case scenario, where we see the data in each Odyssey pass, those 2 Odyssey passes that'll be Sunday night and early Monday morning, in both cases we'll get health data from the rover that tell us how it's doing. We could have to wait until the next morning, though, depending on what happened, and both on our side as well as Odyssey. Odyssey, clearly if it has something happen that causes it to not be listening, then we wouldn't be able to get that data down. So it's very much a question of what happens as in real time as we go through the evening.
Okay.
Emily Lakdawala from the Planetary Society. I know that Mars Express is going to be recording a signal. There's been conflicting information about whether there's actually going to be any data contained in that signal. And so I'm wondering if you can tell me about that and of what use that data might be, considering that Odyssey and Mars Reconnaissance Orbiter are going to be so much closer and receive better information?
Sure. The Mars Express spacecraft will be recording essentially information about the UHF signal. It's kind of like if it's there or not, and we'll be able to see the carrier signal either be present or not in the Mars Express data. And so you are right. We are not going to get actual digital data from that from the Mars Express spacecraft. We'll get a spectrograph, if you will, of what the radio heard during entry, descent, and landing.
It also doesn't occur in real time either. We get it, it's like MRO, where we'll get it recorded. They will record it, and then they'll send it to us a couple hours after landing. So.
Okay, we're going here next, followed by Leo over here, and then on the other side.
Hi, it's Craig Cavalt with America Space and Aerospace America. Question about the DSN configuration. Which DSN station will be the prime one on the landing night when you do go over the hill, and discuss DSN antennas further as to which ones are going to be the workhorse?
So our Canberra DSN stations will be prime for EDL. We also have antennas at Parkes and at New Norcia in Australia, which will be tracking the spacecraft.
Leo Enright with Irish Television. I think probably for Steve Sell, although Richard Cook is pretty good at reassuring us over the years. I was looking at things that might go wrong last night, and I thought I found something that I hadn't noticed before. And that's a thing called the parachute sabot. There was a description somewhere that I read last night which described this thing deploying the parachute and then recontacting with the descent stage to the point that it was quite violent and might even damage one of the radio antennae. Was I being over alarmed?
You might be mixing a few things there. We do have a parachute closeout lid, which is essentially the top of the I guess you can see it right here, the top of the thing that closes out the top of the parachute cone. That does get pushed off the top of the spacecraft when the parachute deploys, but we've done lots of analysis on exactly how that lid behaves after deployment, and it should drift off to the side. We don't expect any recontact there. I'm not sure if that's what you're referring to or not.
Good morning. Irene Klotz with Reuters. I have two questions. The first is for you, Doug. You all have done a really good job in words and pictures of describing the risk of the entry, descent, and landing, but NASA is an agency of numbers, and I was wondering if you did have a probabilistic risk assessment of landing successfully overall, and if there was any particular element in the descent that, from a numerical standpoint, from a risk assessment standpoint, is riskier than the other.
I don't think there's a single number that we can put on this. We rate this. Everybody gets to feed into the risk decision process and the risk understanding process, and so we've collectively agreed that this is as low a risk proposition as possible. But it's almost impossible to put a single number on the probability of success from the top of the atmosphere to the bottom. So, Irene, there's not really a single number. There are analyses that are done, and so you can relate those to risk in every event that occurs. But I think that, it's just such a complicated environment that I don't think that any single number is useful, to tell you the truth. Richard, do you have a different view of that?
No, I think we do, and Steve could certainly talk about it a lot more. We do simulations, Monte Carlo simulations, thousands of cases where we simulate all the different parts of particularly the flight trajectory, the flight dynamics, how the vehicle will, use guided entry algorithms and all that, and we get numbers from that. But that only represents some parts of what the potential risk areas are. It doesn't include things like will the hardware do what it's supposed to do? It assumes that all the hardware will do what it's supposed to do, but it's not, and you get a number that comes out of that, but it doesn't then roll in what's the probability that you might have a problem with the parachute or whatever. And so it's hard to point out a single thing where it all comes together in one, as Doug said, in one integrated number.
Okay, thanks. And for Arthur, could you please explain a little bit more about what that last planned data relay to MSL tomorrow night with the backup computer, exactly what that does? And for Steve, if you could give us the altitudes of the MRO and Mars Express at the time of landing. Thanks.
Yeah, actually, that activity is not a relay. It's a commanded activity on the spacecraft. It's our plan. It's been our baseline plan to activate our backup computer with a set of software that, if in the event, very unlikely, the prime computer reset during EDL, the backup computer would take over and land the spacecraft. So it's always been in the plan to do it at this time, and it's our last remaining significant operational activity.
And as for the altitudes of MRO and Odyssey, I'd have to get back to you on that. I don't have the exact numbers of those.
Okay, we're going to take a couple questions from this side of the room, and then we're going back over there. Go ahead.
Todd Halverson, Florida Today and USA Today. I was wondering who is responsible for bringing the peanuts into the Mission Control Center. And I was also wondering if one of you guys could give us an idea of what your day is going to be like tomorrow, if you have any landing day traditions or special activities that happen, during the course of the day leading up to coming into work. Thanks.
Well, on the peanuts, I think it's everybody's responsibility to bring peanuts.
Because of that, we have 50 jars.
So we have plenty of peanuts. And the mission manager usually assures that we don't run out. With respect to traditions on landing day, I think it's traditional to take a deep breath when we finally get there, and reflect a little bit on how far we've come and where we are. So I think there's a moment of joy and a moment of reflection as well.
Yeah, my version of that would be as well that usually when you get to the last day, there's not that much to do, right, other than to wait. And so usually you get a chance to go have coffee with some people on the team and to do exactly what Arthur said, right, which is to say, okay, it's been a long trip here to get here, and it's going to be an interesting next few hours. And time seems to have a weird sort of rhythm in that last day, right, where it goes real slow for a long time, and then in the last 15 minutes it goes like that. And it really goes quickly, and all of a sudden it's upon us. And so that's what will happen.
Hi, Mark Kaufman with the Washington Post and National Geographic. Editors, of course, are very eager to know when might we know that the thing has safely landed. And I know that there's the 14-minute distance gap, but what should we be telling our editors in terms of the earliest moment, the likely moment, and I have a second question as well.
I can tell you that touchdowns at 10:31, 10:32. There is some variation on that due to atmospheric changes that change how long we might be on the parachute, but essentially we're within plus or minus a minute or so of 10:31, and if we have Odyssey coverage throughout, if the Odyssey coverage remains all the way through, we'll be able to follow it through touchdown at that time. As Richard mentioned before, there are scenarios in which we, for any reason might not have the Odyssey data available, in which case then Richard went through the several opportunities after that we could know what happened.
Scenario that then would be 10:45 or so, and how would we be informed?
No, the 10:31 number is Earth receive time.
Oh, that's Earth receive.
Yeah, so it will. Yeah, that's an interesting thing to point out is that we're actually watching the whole thing on a 14-minute light delay. So it actually touched down 14 minutes ahead of that, but when we find out here is 10:31.
And how would we be informed?
You'll probably be able to tell by us celebrating.
Yeah. When everybody starts high-fiving each other, that's
usually a good sign.
Okay.
Under the case that we don't know, then what we're going to go into is we'll have either a press conference or a report out of the MSA as to what we think we know, and some member of the team, probably Pete, will give a briefing as to what we think we know, and then we'll wait until that next Odyssey pass at 12:30, and we'll by that point, by the way, have shipped